Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Welcome to all audience, especially to our professors, associate professors, doctor, colleague, lecturers, and to all students from mechanical engineering to also mechanical automotive engineering and the rest of the audience. Okay, so today we will have a presentation from Dr. Izzal. Just to give you a brief introduction about Dr. Izzal, which is after graduating in 2007 from Tokai University, Japan. Dr. Izzal was employed by Proton, our national car, with 6 years experience in automotive industry. He joined then Imperial College to pursue his PhD in November 2013. And then his primary research is focused on developing a turbocharger matching method for one-dimension engine simulation software that enable better engine efficiency and transient response by incorporating more representative model for waste-gated turbine and electric turbocharger system. During his PhD, he also worked on industrial research project with Mitsubishi Heavy Industries, including a collaboration with Group Renault from France, the major passenger car manufacturer, and the turbocharger supplier Mitsubishi Turbocharger and Engine Group. And after completing his PhD, which is in 2017, Dr. Izzal worked as a research associate on collaborative industrial research project with MHI until 2019. And currently he worked at UMW Innovation and R&D Center Sdn Bhd as Head of Product Innovation. So without further ado, I will come and pass this session to Dr. Izzal.
Thank you, Dr. Zuhailmi. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. To all lecturers and all UTM members. Alhamdulillah Rabbil Alamin wassalatu wassalamu ala ashrafil anbiya wal mursalin wa ala alihi wa sahbihi ajmain. To give a webinar talk to all UTM members. And then I was told this session is more majority from automotive engineering students. So I will share, I prepare my slide, basically focus on the automotive perspective. And I will talk about my life journey. That's why I put like a experience as and knowledge sharing session to all of you. So let me share my screen. Okay. Okay. Nampak tak? Can someone confirm you can see the slide? Okay, all right. So the topic for today is engineering the future of tomorrow. So I will share my experience throughout my life journey, and I'm sharing my knowledge a little bit. So I'm currently heading a product innovation team under UIRDC, which is UMW Innovation and R&D Center Sdn Bhd. So next slide is, this is the content for today. I will explain a little bit about my background, my education and working experience. I think just now Dr. Zul already mentioned, but I will repeat it again. Go through in a little bit in detail, and current engineering challenges and we need to prepare for the future. And our task and responsibility, and I will go for the conclusions for today. So background, education and working experience. So this is my background, my education experience. Saya bermula di Sekolah Kebangsaan Tuanku Fatimah, Bentong, Pahang. I'm orang Bentong, Pahang actually. And then after that, with the result, I pursue my study di Sekolah Sains Sultan Haji Ahmad Shah Pekan, Pahang. And then with the results, and I highly involved in curriculum. I involved in football and forum, basketball, and I did a lot of curriculum activity, and like as a captain rumah sukan biru. And then I got opportunity to further study to Japan, which is 2003 till 2007, this is a program ijazah berkembar Jepun, Japan Associate Degree, which is this one initiated by Tun Dr. Mahathir. If you still remember, is Dasar Pandang ke Timur. So at this time, I spent 2 years in Bangi. First year is Japanese preparation. That's the first time I learned Japanese actually. I didn't learn Japanese when I was in Pekan. So the second year in Bangi, that is the first year of university. And then that is the twinning program. And 2004, I went to Tokai University. So it became like a second year of university, second, third, and fourth year at Tokai University in Kanagawa, Japan. So I took prime mover engineering, which is like a automotive engineering. The primary things that you want to move something. So that's automotive engineering. And after I graduated in Japan, I continued back to Malaysia, and I worked with Proton. At this time, Proton sent me in 2009 to Lotus to build a CFE engine, it's turbo engine. And I also being seconded in Ricardo Showroom by Sea, Brighton, UK, to develop a new engine, so-called new engine family, TGDI family, TDGI engine for Proton. Unfortunately, the project ran down due to several reasons. So I've been with Proton for 6 years, and then I got opportunity to continue my PhD at Imperial College London, UK in 2013. So I went to Imperial. I highly involved with all industry, Mitsubishi. I went to Netherlands, Mitsubishi Turbocharger and Engine Europe. That's a turbo company, turbo supplier. Also worked with Renault. They gave us a Renault 1.2 turbo engine. So I collaborate with them. And with this collaboration, I managed to produce several chapters in my thesis. And then after I graduated 2018, Alhamdulillah, I got opportunity to work with MHI, but I working with Imperial as a research associate and collaborate with MHI Japan, working on the heat transfer on effect on turbocharger. So for 1 year, and then I decided to move back to Malaysia, to settle down in Malaysia in 2019. I got offer from UMW to set up a R&D center for UMW, so-called UMW Innovation and R&D Center Sdn Bhd, UIRDC. That's why what I'm right now, which is I'm heading the product innovation, execute the innovative product for UMW. So if you can see, 2021, I was selected by IUMW, International University of Malaya Wales, as IAP, Industry Advisor Panel. And then 2022, this year and 2023, I've been appointed by UTM as a industry advisory panel for UTM for 2 years. So that's a little bit about my education and working experience. So I can show you, this is some picture, my final year project in Japan, which is I involved in setting up HCCI engine, homogeneous charge compression ignition, which is that in between gasoline and diesel, which is that engine can spark or can combust spontaneously, which is that's between diesel and engine, which is my final year project to set up the HCCI on the Yanmar diesel engine with new technology common rail system project with my Japanese team. You can see there is a high pressure common rail, need to supply with the high powered motor, and then you can see at the right hand side the yellow engine, that is a Yanmar diesel engine. So that's my final year. I think this is quite interesting. I need to analyze and simulate the injector readiness using software so-called Wavelogger Pro. That's something new for me, and this is a very interesting experience when I was in Japan. And this is my graduation day, 2007. You can see I'm with my all Japanese team under Professor Chen in HCCI team and also fuel cell team. We do research on the HCCI engine and fuel cell engine. And the right bottom, that is my Malaysian colleague. Now every separated, ada yang bekerja di Produa, Shinetsu, ada yang still remain in Japan, working in Japan and so forth. So that's a very good experience for all of us study in Japan. And then the next slide, this is the evolution of Kempro Proton engine, which is, I think all of you quite familiar with Proton engine, which is we start with base Kempro 2004, and then which is we benchmarking Mitsubishi engine, and then we upgrade with the Kempro IFM intake air fuel module, and then we upgrade again. We have some modification. We call it in 2007 Kempro cam profile switching, which is Kempro CPS, which is Kempro IFM. We design the intake manifold based on the air requirement, which is we have the long runner during low RPM. At high RPM, it will automatically shifted to short runner due to air and fuel demand. And cam profile switching 2007 is we switch the camshaft from low lift to high lift, which is at low RPM, camshaft rotate at the low lift strategy, and high lift will selected at certain RPM, if I'm not mistaken, at 3,000 or 3,500 RPM. It will lock at that high lift to make sure that there is more air can enter the engine. And then 2011, that's the new version of Kempro, which is that's the one that I went to Lotus 2009, and it was launched in 2011, which is we put a turbo. This is where that is not easy because we need to do some engine matching, turbocharger matching, which turbo that's suitable to Proton Kempro. So I think if I'm not mistaken, we choose we have several types, we have several options, and we end up using Bob Warner brand into Kempro CFE turbo. So you can see the right hand side, that's me 2013 with all the engine turbo production in Shah Alam, and the bottom one I'm at Lotus Norwich, and also Ricardo Showroom Technical Center at Showroom IC in the UK. Okay, this is the I think some summary that I explained just now about the Kempro launched in 2004, the first very own engine. It was used on the Proton Gen 2 Kempro and also Wajah Kempro 2007. And the second one, Kempro IFM, was launched back in 2008 and improvised the version of original Campro, which is IFM, stands for Intake Air Fuel Module. So it is used for Proton Persona till now, and also Saga BLM, baseline model 2008 until present. And then the third one is Campro CPS. Like I mentioned, CPS stands for Cam Profile Switching, and used for Proton Wajah CPS and also Izora CPS. I think you still remember we have Izora MPV that use CPS engine, and also Gen 2 CPS. I think because of Izora CPS is a little bit underpowered. That's why we come with the Proton with the turbo engine, the Campro CFE. Campro IFM CPS, I think the torque is about 150 Newton meter, while the CFE torque is 205 Newton meter. And we target the transient at low engine speed, which is that's why we choose the small turbo, because we focus on the low RPM, which is we target on the transient response rather than we choose the big turbine, the big turbo for the high end, for the more powerful engine. But I think for Proton, we choose the small turbo that's focused on the low RPM to get a better transient response at low engine speed. And then this Campro CFE first introduced into the market with the launch of Izora Bolt Prime in December 2011. Okay, this is a little bit picture. The left top, I was in LG Vans in Korea. We discussed on the Izora MPV packaging. So I'm one of the packaging engineer that to make sure that all the components need to be fitted nicely in the engine bay. There is no interference between all components. And then I'm also, you can see a little bit some pictures I just drag into this slide. That's my involvement in the UK, in the Lotus, and also at the Brighton with the Ricardo team. And then I went to Imperial. So this is my turbocharger team members. This is at the entrance with my supervisor, Professor Ricardo Martinez Botas, and also my co-supervisor, Aaron Costal. And you can see we also took a picture in the Turbo Lab. And then again, this is my turbo colleagues. You can see, I think you can see similar faces from UTM, Dr. Srita, Dr. Ittisham, Dr. Hasbullah, Dr. Izwani, and also Dr. Uswa, which is, they are in my team as well under Professor Ricardo. And then, okay, this is some of my research, which is, you can see there is a study research on the turbo scroll, turbine housing, on the single entry, on the twin entry, on the double entry, on the mixed flow turbine, on the radial flow turbine. So we did research on the performance on the turbo, which is we have a cold test rig at the Imperial Turbo Lab, which is to identify the performance of the turbo. And you can also see at the right bottom picture, there is you can see all the green wired. There's a collaboration with Mitsubishi Japan, MHI Japan, which is we need to measure the temperature at the intake turbine, outlet turbine, and intake compressor, outlet compressor at the cartridge. So you can see multiple thermocouple in that picture, which is that's part of heat transfer effect on the turbocharger project with MHI. And the center bottom, that's a 3-cylinder engine cross section, which this is like a cross section that we need to understand what is the component inside the turbo. And this is my convocation day 2018 at the Royal Albert Hall, UK. And my colleagues take picture with my supervisor, with my family, and so forth. And then just to share with you, in 2018, this when Tun Mahathir was our Prime Minister. He visited us at Turbo Lab in Imperial College London to seek advice on the EV, potential EV business readiness in Malaysia. So he went to Imperial. Professor Ricardo asked me to lead the Turbo team to welcome Tun Mahathir. And I think that's a very good discussion between our Prime Minister and Professor Ricardo, which is like my professor said, the readiness of EV is more on the infrastructure, because if we want to have a full EV, we need to have an infrastructure, all the charging station from Johor to Perlis, for instance. So we need to have a ready infrastructure before we embark the EV vehicle in Malaysia. Other than that, we can only use the EV vehicle in the control area, like in Putrajaya, for instance, like in the very short distance area in Malaysia. On top of that, we also explain the readiness of using hybrid vehicle at this moment. Okay, 2014, this is the, I think you're familiar, I think this is familiar at UTM Lokartik, low carbon transport, under Dr. Srita. So we took a picture, we are launching the Lokartik in cooperation with Imperial in 2014, which is, you can see there is Professor Dr. Wahid Omar, next to Education Minister at that time, Tan Sri Muhyiddin Yassin. And this is some activities that I would like to share with you. There is a cooperation between Lokartik and Imperial College London. Okay, this is my colleagues, Turbo comrades, which is Alessandro Romagnoli. So my friend is all over the world, which is I have Alessandro Romagnoli now in NTU Singapore as a lecturer. And Ming Yang in Shanghai. Professor Ricardo Martinez Botas is my lecturer. Peter Newton in UK. I think now he's working in in Ministry of Transportation in the UK. We have Konstantinos Kolilas, which is I call it Kostas, the Russian guy. I have some friend with Alex Carl Pepe BJ, my Turbo very best friend, and Apostolos and Simon, which is this is during my Viva time. And Matthias Abel, the German guy now working with Daimler, and also the MHI team Japan. This is the one that we collaborate together with MHI Japan. And I have also a friend with Esperanza, now working as a research associate at Imperial. Pepe back to Spain, working with his innovation company. And then the right hand side, the Yorick and Laura here, working at the Mitsubishi Turbo Engine Europe. When I was seconded in MTE in the Netherlands for, I think, for 3 months. And also Malaysian colleagues, I repeat, use the same picture. You can see the same. I'm very close with UTM and also several lecturers in Malaysia. We have Dr. Srita, Dr. Hasbullah, Dr. Ibtisham, Dr. Izwani, Dr. Uswa at UTM Semara, and also Dr. Wan Saiful Islam, my best friend, now in UTHM. Dr. Bala, now UPNM, and also Dr. Aman Ihsan Mamat, which is at UITM Shah Alam. So we move back to Malaysia and try to give back all our knowledge to community, Malaysian community and society. Okay, complete my background. I would like to explain on the engineering challenges, preparation for the future. So I'm taking automotive engineering as an example, because currently when I working with UMW, I have to deal with not only automotive, I have to deal with all engineering background, which is currently we work with the chemical engineering, design, product design, electrical engineering, water engineering, and there's a lot of engineering transformation. So we need to combine all together to make sure that we have a good product for UMW. That's what I'm doing right now. So if I'm taking automotive engineering as an example, I'm just sharing my knowledge, my experience. There are thousands of engine component in an engine. We can see there is a crankshaft, cylinder block, camshaft, piston pin, piston ring, all the the front end assembly driven, all the filter, aircon compressor. There's a lot of components in an engine, and for we as a automotive engineer, we have to make sure that all the component need to be designed and analyzed to make sure all the component is suit all together. So I can share with you to make an engine fitted into a vehicle, it would take from scratch. I would say it would take about 24 months, 2 years to start from A to Z to design an engine, to produce an engine. You start with engine benchmarking. For instance, if you want to do a CFE turbo engine, we need to do what kind of engine that we would like to compare. Are we focusing on the low end torque or are we focusing on the high end power? So if we have that particular selection, and then we need to put what is the potential design strategy for that for that engine. So we do benchmarking, and then we can do our design engineer can start a design all the components. There is a design engineer for crankshaft, design engineer for cylinder head, design engineer for piston pin, piston, connecting rod, and so forth. And then once the design completed, the design need to comes together with analysis, design analysis. We do have the 1D simulation by calculation. We also have the 3D simulation, which is we need to mesh, we need to do a finite FEA, finite element analysis, to see what is the fatigue factor, where is the the strength with the stress factor, fatigue area at that particular design. And then there are some iteration between design analysis to make sure that that design fulfill the engine team requirement. So in Proton, I think in other OEMs, they also have the SSTS, sub-spec technical specification, which is it will identify the target performance of the engine and also the target performance of the vehicle. So once the design and analysis completed, we do the rapid prototyping, and then we have that prototype, the real prototype, and we put all of the component all together, and we do the testing at the lab conducted by engine development team. And then we do testing and validation, which is that engine meets the performance of from our SSTS. Like for instance, that CFE, we have the target of 205 Newton meter at 1,800 RPM, and the power of 103 kilowatt at 5,500 RPM. So we have to test and at a full load throttle every single RPM to make sure that that engine meet the requirement. So that is a testing and a validation activity for that engine. And after that, the system integration, which is that once the engine phase completed, it will need to fit into the vehicle. So that's another story, because once you put in the vehicle, you need to match with the gearbox, with the transmission, with the automatic transmission or CVT transmission, and fit into an engine in the engine bay. So there's a long story again. So I'm talking about the engine at this moment. So like I said, there is a engine benchmarking, and there is also the POWERTRAIN dynamic analysis, coolant jacket analysis, and also there is a CFD work, blade streamline, to see how good of the turbine flow affecting the engine performance, and also the crankshaft fatigue durability analysis, and also the exhaust manifold conjugate thermal analysis. So this is not this requires more than 10 or 20 engineers to make sure that the engine is well designed and well validated. Okay, I put again, this is the left top picture. There is a common explanation on the the fuel efficiency, which is if we use 100 of fuel, we can only get 30 to 40% of useful work, and the rest goes to exhaust and coolant. So that's why the turbocharger act like energy recovery to use back the energy, the exhaust energy back to the engine. So if you can see the graph that I put here, the CO2 requirement, the emission requirement over the years getting more stringent over the years, and we're expecting in 2025 or 2021 the CO2 emission will reduce even less than 100 gram per kilometer. So because we are using gasoline, we are using diesel, we have the hydrocarbon in there, so it will pollute emission to the atmosphere. That's count the CO2 numbers. So that's why we are working intensively on designing an engine, or we change the ICE engine, internal combustion engine, to something else that reduce the CO2 emission, like a hybrid, or we downsize the engine, like we use a turbocharger, which is we have the same performance but less surface area, thus reducing the CO2 emission value. And also even now we are moved to EV vehicle, which is there is no using ICE, which is we are using full electric vehicle to move the car. So this is some effort, like we use multi-boosting turbo into an engine. We downsize the engine, and for this one we managed to. I think this is quite old. I think it's 2013, 2014 when I was at Imperial last time. The turbine for electric compounding, which is with this architecture, this engine managed to get 100 gram per kilometer with 38 better fuel consumption. So this is some effort to make sure that we achieve that CO2 emission with a downsized, very small engine with powerful performance. And this is also Ultra Boost, which is to develop an engine concept that capable of 35% CO2 reduction, and this is compared to 5-liter V8 NA engine, naturally aspirated engine. And this Ultra Boost engine also can remain the performance, emission, and also the transient response of that benchmarking engine. So I think this is like a combination over the years, maybe until 2025 trend, people more tend to electrification. But like I said, there are some evolution on the engine, which is come with the common engine, standard engine, which is naturally aspirated engine, and then they downsize the engine. The naturally aspirated is come with the PFI, port fuel injection strategy, or gasoline direct injection strategy, with using the petrol, using the diesel, and then to reduce the surface of the areas of the engine, it downsize the engine and put the turbo. And then it goes for the hybrid, which is there is a battery combination between the battery and ICE engine, and then it goes to the full electric vehicle. So that is a trend over the years. Okay, there's some explanation on the automotive engineering. So when I work with UMW, so my responsibility, my task is getting broad, because when UMW appoint me, they want UMW to have UMW own product. So before that, I would like to share with you the video Actually, UMW now is already 105 years old. So I would like to share with you from automotive to aerospace, because if you talk to anyone else, cakap je UMW, all in mind 90% UMW Toyota. Is because we have 4 division. Actually, we have 4 division. We have automotive, equipment, M&E, and aerospace. So Toyota is fall under automotive, but we have another 3 division. So I would like to share with you this video, and please enjoy, listen to this video, what is all about. UMW is all about.
It all started 100 years ago in a humble spare parts shop. Our founder, Izzal, was fascinated with engines, which sparked ideas that would revolutionize different industries. We wondered if getting good at one thing could make us good at another. What if building powerful, heavy equipment could help us make reliable cars? What if manufacturing led to venture into oil and gas? Or venture into aeroplane fan cases? That led to investing in technology and IT services. Which then paved the path for building a high-value manufacturing park. We've all made it possible, and as we move on to the next 100 years, we'll never stop breaking boundaries and going beyond what we set out to achieve.
Okay, that's video. Okay, so basically UNW is a GLC company, which is almost more than 60% under PNB, and then 20% is under KWSP and also KWAP, Kumpulan Wang Persaraan. So we do have, we operate in 8 countries, 70 companies under UNW, and 16,000 employees. And it started in 1917, like in the video mentioned, with a bicycle repair shop, and evolved until we have a partnership with Rolls-Royce to make a fan case. And like I mentioned, we have 4 main division, which is automotive, which is we do have Toyota, Lexus, and Prodwa. And then equipment, we are selling, we distribute trading, leasing, after sales service on the Toyota forklift, Komatsu, and so forth. And we also have a M&E. You can see the Kayaba at Teluk Paling Megarang, shock absorber in Teluk Paling Megarang. We also have the lubricant products, Pennzoil, and also Grant. That's under premium product by UMW. And we also start aerospace business 2017, which is we have a 25 years contract with Rolls-Royce to on the fan case, Rolls-Royce Rolls-Royce and sent to Singapore and sent to the US for Boeing aeroplane. So I would like to explain about my company right now, which is UIRDC under UMW. It just established because we want to centralize all the R&D activities under one company, which we just established in last year, January 2021, and we set up innovation labs in Serenda in August 2021. I think some of UTM members, MTech team, ADC team, when already came to my lab to see what we have in the lab, and we can further collaborate together. And then we located, UIRDC located at UNW High Value Manufacturing, HBM Park in Serenda, just opposite side of Produa. And our lab, we have IR 4.0 lab, we have battery lab, we have biolube lab, biolubricant lab, and also membrane lab. So if you can see, there is our building, UIRDC, and inside there is our lab at this moment. And we might expand our lab based on a future project, inshallah. Okay, this is the map, UMW HVM Park. You can see the UNW is just opposite of Produa. And I just want to share with you, we apply open innovation approach. Okay, top management instruct our team to make sure we need to have UMW product. So what is our potential product? We need to exchange the information and collaborate the ideas with all parties. That's why we apply open innovation approach, that we can diversify the idea, and then to ensure that what is the product that can successfully enter the market based on needs and so forth. So we always collaborate with government agency. We meet MIDA, we meet MGTC, National Green Tech Company. MIDA ask what is the needs, what is the demand right now, and also we meet all the industry player. We do some benchmarking. What is a good product? We ask the subject matter expert based on their experience, what is the pain point for customer, and then we also engage with university. I think since last year, I visited a lot of universities, including UTM, UITM, UITM, UPM, UMP, to see what is the good prototype that can be commercial. Because we can see that at university, most of the university do all the prototype based on the expertise of the department, and maybe not tend to commercial because of investment, because of several factors. So maybe we can assess. My team always went to the university and assess whether this product is possible, has potential to go to the market, and then from there we can further investigate and further discuss. And if that's potential to be presented to the top management, we'll bring it the proposal to top management, and we get the funding from them to commercial that product. That's for example. And this is a triple helix collaboration and development cycle. Like I said, I visited several universities like UTM, UPM, UMP, and then we also asked about I think all universities has their own prototype, their own product, but with different TRL, technology readiness level. I think UTM also, maybe some of the students not familiar with the TRL. So maybe you can explore more. You can even Google. That is from NASA, which is to show the readiness of the product to enter the market. Normally, TRL 1 to 4 is more on the basic principle, formulation of concept, experimental proof of concept, and lab validation. Once the proof of concept ready, it goes to the TRL 5 to 7, which is the prototype, need to be validated in real environment, in relevant environment. You can do in the lab, in the closed building that mimic the real environment, and then you can validate that product in the real environment. and so forth. And then there is a TRL 8 and 9. You need to get certification for that product. Maybe in Malaysia, you can get the certification for certified body to certify the product. For instance, SIRIM or TUV that have the certified testing that produce the report that this product is the performance of this product is this and this and meet the target, something like that. So but need to be certified by the certified body. And then 9, if the TRL 9, which is that product is matured and is ready to be commercialized. And then what from this graph, what I can see, what I can explain, the participation rate of university most on the early stage, which is at the proof of concept and prototype, but not for industrialized, which is at the scale up stage and commercialized. So you can see universities from top going down because the participation rate very high at the in the beginning and goes down. But for industry like UMW, we don't do so much on the proof of concept and prototype. We're going up because we need to scale up and commercial because we are business company. It's all about dollar and cents, about revenue and so forth. So rather than we start from zero, why don't industry collaborate with university to get a very good prototype and we validate based on 4 perspective. Normally for university, they look into technical perspective, whether the product is good or not, is meet the Navier-Stokes equation or not, the with all the ideal mass flow, all the fundamental things. But there are another 3 perspective that we need to put into consideration before we want to commercial the product, which is technical, financial, whether the product, the raw material is cheap or not, is it affordable or not. That's the thing that we need to consider. Technical, financial, commercial. Is it boleh jual ke tak? Is it there is demand or not? Is there is need from customer or not? And L, legal. So the product need to be legal. Need to be legal lah, not illegal. So we need to get some certification standard from certified body. So maybe I can the 4 points that we need to assess before we choose the prototype to be collaborate together with UNLU is TFCL. Please remember, technical, financial, commercial, and legal. So this is about some explanation on this slide. And then, okay, I want to share with you a little bit on our current green innovation project. We choose based on 3 main elements. We have engineering point of view, engineering elements, innovation elements, and also sustainability elements. We need to have the product, but that product can be sustained in more than 10 or 20 years. So before it expired, we already identified we need to change with another product. So the product also need to be sustainable. So currently we have 3 projects, which is we have battery management project, battery at battery lab, membrane project at membrane lab, and biolubricant project at biolub lab. So this I will explain about the UMLU what we are doing right now. So on top of that, we also have one IR 4.0 lab, which is this is to support our innovation project, which is we have 3D printer, the low end 3D printer and also the high end 3D printer. We also have the laser cutter, and we can do some prototype because at this lab we also get some several intern from university, and we also have the SolidWorks software. You can design some several parts and then convert to 3D printer. We have the prototype, and we can there is some design and analysis activity happen in IR 4.0 lab. We have a laser cutter to cut the acrylic or to cut the foam leather and so forth to support our innovation projects. We also have the cobot, just to mention that UMW Industry also distributor of UR, Universal Robot. So if you more interested on the UR cobot, you can contact UMW Industry. So this is battery lab. Okay, we do battery research and testing. We understand the battery terminology, But for this stage, we are focusing on the lead acid battery to extend the life of lead acid battery. But we do have our own our roadmap, which is not currently we focus on the lead acid battery because the demand of lead acid battery is there, and we will focus on the nickel cadmium, the lithium ion, and solid state battery. We have our own roadmap in next 5 years. So for lead acid battery, we tend to extend the life of the battery because 80% of the lead acid battery on the road dalam kereta kita, battery kong due to sulfation because of we have an anode cathode plumbum plus PbO4 PbO2 plumbum oxide plus we have an electrolyte H2SO4 acid sulfuric. When we discharging, it will go to PbSO4 plumbum sulfur and H2O water, and it will irreversible cycle, and we discharging, and at over the time the acid sulfuric will form into plumbum sulfur yang macam color putih tu melekat dekat bateri tu, which is tu tak boleh nak back to acid sulfuric. The creation of plumbum sulfur will reduce the battery performance because of it will increase the internal resistance of the battery. Dia akan melekat dekat plate bateri tu. So it will reduce the battery condition lah. So lama-lama melekat, lama-lama bateri tu tak boleh nak start because the voltage drop. So we have some patented algorithm. We have patented algorithm. We dah patentkan the algorithm dekat my IPO. So the desulfation process from plumbum sulfur back to acid sulfuric in efficient way. So sekiranya that battery can be no plumbum sulfur creation on the battery, it will life longer. So we plan, so for a common battery in the car yang biasanya kita pakai setahun, 2 tahun, battery dah kong, we need to change with a new one. With that strategy, battery management, before it form into the crystal sulfur, kita dah already desulfur dah that sulfur back to acid sulfuric. So the battery can last longer, up to 3 times, maybe 5 years. We put like 5 years. The battery that normally we use 1 to 2 years can be used until 5 years. So it's good for environment because recycling, we don't need to bring that battery to the recycle center. We can reduce the number of battery recycling. We can extend the battery life. So that is the one of our R&D, and it is already commercialized, but more on the business to business approach. Okay, in the lab, we also we study the terminology. We also have the equipment, battery discharging device. We have all the SG hydrometer and so forth. And you can see at the right, we also collaborate with ADC, Automotive Development Center, with Dr. Zol and Dr. Azman to build battery simulator, which is we have the device that can apply several load based on kita punya setting dekat MATLAB. Dia punya turun naik dia replicate the real environment to make sure that the condition of the battery tu okay, and then we will put in the lab lah to understand the characterization of the battery. So this is one of collaboration with ADC UTM. So I think this is the that what I mentioned just now, because of our effort, our aim, our vision to reduce battery pollution by extending the battery lifespan. Nampak yang dekat bawah tu discharging for desulfurization, discharge. So you can see the white things that is sulfur. So how to desulfur in an efficient way, itu we already patented, because kalau we apply current on that battery, tapi kalau current tu terlalu tinggi, it will crack the plate. So there is a cycle that the secret, there is our recipe to make sure that sulfur can be desulfurized in efficient way without touching, without damaging the plate in the battery. Okay, the next project is biolubricant lab. Okay, biolubricant, we do lubricant things, lubricant research, because I think all of you already, maybe some of you knew that we have Lubtex Sdn Bhd, that we selling the Pennzoil lubricant and also Gran lubricant, but all of them is mineral based. That is mineral based, which is we take the mineral base is toxic lah. Kalau sekiranya that lubricant jatuh ke tanah, dia akan jadi toxic. So in green and sustainable punya environment, we are using plant based. Menggunakan plant based, kita punya formulation dia tak toxic, biodegradable and non-toxic. Sekiranya lubricant jatuh ke tanah, dia akan degrade in 28 days. So and sekiranya kena dekat sungai, masuk dalam sungai pun aquatic tak mati. So itu dia punya value proposition, sebab dia akan menjadi demand kalau if you still remember in Selangor lah, for instance, terlalu banyak sangat, setahun macam jadi acara apa, air tak ada kan, air tak ada. So disebabkan kilang-kilang banyak dia buang lah minyak hidrolik lah, letak kat sungai, terpaksa stop dan nak make sure tak kena pada ni kan. So itu adalah salah satu effort kita nak buat biolubricant menggunakan plant based to make sure sekiranya benda tu jatuh ke tanah ke environment, dia tak toksik dan selamat pada alam sekitar. So kita ada beberapa stage roadmap juga. So we start with biodegradable lubricant, and we also have the food grade lubricant. Food grade ni kalau termakan pun tak mati. Tak makan, kalau termakan pun tak sakit lah, sebab dia from plant based, 100% plant based. It's food grade punya quality lubricant. So we have roadmap also for this biolubricant lab. We also have several advanced equipment and machine, TOS for oxidation stability. We also have the homogenizer and also test kit to testing the water content and so forth. And this lab juga kita collaborate dengan ADC. If you can see dekat belah kanan tu, that is the FZG gear tester, which is one of requirement untuk kita nak commercialkan this product. This biolubricant need to meet ISO 15380, for instance. 15380 ni, one of the compulsory testing is FZG gear tester. We need to put that lubricant in the gear, and kita ada letak several load to make sure that metal to metal tu tak ada scuffing. So maybe you can Google more to understand about the FZG gear tester. In Malaysia, no one conduct this FZG gear tester. In fact, SIRIM pun tak ada. We need, for this biolub, we have to send our lubricant, our biolubricant to UK, which is very expensive, the testing, but in order to get that certified report, we need to send to UK, which is very expensive. We get the result, okay, pass, but rather than for this year and next year, I want to have that FZG gear tester in our lab. So we collaborate with ADC, and this is a very interesting collaboration, which is we refer the ISO and ASTM standard. We make exactly what in the standard and now already in our lab. So you can see Dr. Azman and Dr. William visiting my lab and send this FZG gear tester with all the ADC team. Thank you very much. So we have the gear tester. So we can do the testing with a specifically like a ISO and STM standard. Siapa yang nak bagi certified report? Because our lab is not certified. So there is another collaboration that we can collaborate with SIRIM. SIRIM is certified inspection body. SIRIM members boleh visit our lab, witness the lab, also conduct the lab, and SIRIM boleh keluarkan certified report for this FZG testing. So in the future, we don't need to send this our bioloop to the UK. We can do the testing in-house in Malaysia. So rather than we use FZG gear tester for UMW, we can also provide services to anyone that want to do FZG testing. We can do dekat UMW biolubricant lab. So that's one of the effort from my team to make sure we have unique equipment and machine, rather than we just copy, we just buy exactly the same machine equipment from other company, so we don't have any value proposition of our machine. So this is a value proposition unique our machine, which is no one can do. We can complement each other. So this is one of the equipment machine that we have in BioLoop lab. So this is, like I mentioned just now, the mineral the mineral based water. 1 liter oil can pollute 1 million liters water and then poison the soil of agriculture, and our effort to make sure that we have sustainable sources from plant-based and also biodegradable and non-toxic. The next, our roadmap is food grade grease. So that's why our product, which is biodegradable and non-toxic product, lubricant. And last but not least, we have a membrane lab. I think most of UTM people already identify UTM have AMTEC, Advanced Membrane Technology Research Center. So we already collaborate with AMTEC to commercial the product. So we do have the bioreactor system. This is a proof of concept. And also we have incubation and spectrophotometer to analyze the chemical of sample and so forth. So this water filtration also is a demand because of the water demand years by years is increasing because the number of population and also the industry require water more. So rather than we just to inform you, for this membrane lab, we focus on the water reclamation plant. All factory, all industry, kalau contohnya kilang chemical, kilang cat, sebelum dia menggunakan air kat dalam kilang. So air tu sebelum dia discharge to the river, dia sebelum tu memang ada water treatment system. Water treatment system tu dia kena make sure water tu diproses up to standard A ataupun standard B, depends on the location of the factory lah. Contohnya macam di Kayaba contohnya, di Teluk Parlimen Garang, dia kena make sure air yang dia nak discharge to the river tu kena meet piawaian standard B. Okay, so dia memang ada water treatment system prior to discharge to the river. So kita UMW collaborate with AMTEC, kita buat water reclamation plant. Kita ambil balik air yang nak discharge to the river tu, to the longkang tu, kita ambil, kita proses balik dan kita boleh pakai balik air tu ke Kayaba balik. So that's a water reclamation plant, and also maknanya kita reclaim lah, kita reuse balik air yang dah diproses tu untuk pakai balik ke industri, rather than benda tu pergi ke sungai, proses balik kat Syabas, hantar balik ke Kayaba. So kita pakai balik that water reclamation plant back to the industry. So I think in 2025 maybe Ministry Kementerian Air dan Alam Sekitar akan membuat satu akta yang semua factory akan require compulsory to use that water reclamation plant. So UMW, we are ready for that. We try to grow our team. We have a water solution engineering, we have a design water expert. We try to develop our team to make sure that we are involved in this water engineering projects. Okay, conclusion for today. 3:30 dah. Okay, conclusion for today. So basically, I just want to advise to all of maybe to the student, we just need to prepare ourselves for the future. Okay, knowledge and experience help you grow. Please involve anything that you have in university berkenaan dengan communication skill, networking, all the engineering things, semua tu akan di-apply once you work in industry, for instance. I put doing nothing at all versus small consistent effort. Maknanya buat sikit-sikit tu akan dapat dia punya benefit at the end, rather than tak buat apa-apa. So please do something for yourself, okay? And then number 2, university provide you an educational platform to grow as well as leadership skill, communication skill, and networking. Participate in club and society. So make yourself active lah, supaya kita ni akan menjadi pelapis negara in the future. So prepare yourself. Okay, number 3 is understand the needs of the future. Nak buat sesuatu tu kita kena identify what is the needs. Ada needs ke tak? Ada demand ke tak in the future? Kalau ada, try to be something yang ada add value for the future. And then passionate towards works lah. And then to make sure that kita ni ada complement, kita ni menjadi asset kepada negara, not menjadi liability kepada negara. Okay, that's all from me. I think anything you can ask me. I think nevertheless, this session I just want to share with all of UTM members my experience throughout my life journey, and I'm not representing anyone. I'm just sharing my experience and knowledge. That's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
So thank you very much, Dr. Izzal, for that presentation, which cover a vast areas, which is from his own experience doing PhD in Imperial College, and then go to a more specific area that we can see in engine, turbo, electric vehicle, hybrid electric vehicle. And Dr. Izzal also have touched on the general work experience as automotive engineer, UMW also, with 4 division before he go to some information on UIRDC. Okay, and the work that they have done there with their product development and also the green innovation project that have been conducted and still going on. And close by some important advice to our student. Okay, some important advice to our student before they jump to working experience later on. Okay, so I was hoping actually to have some question from you, our audience, but so far in the
Dr. Zul,
what no what
Dr. Zul,
is that? Yes.
maybe I can add sikit. I just nak advise pada student, to all student, sebab untuk to get professional engineer, okay, professional engineer IR, after you dapat scroll degree from UTM, you terus register BEM, Board of Engineers Malaysia. Okay, please Google BEM, tolong register. Once you get the scroll
Yes.
degree, terus register. Sebab untuk apply professional engineer, dia punya industrial experience, it counted after you register dekat BEM untuk dapatkan as a graduate engineer. Kalau you tak register, tak dapat, it's not counted. So please, once you dapat your degree, terus register kat BEM. So you kerja lah mana-mana, you can collect all the industrial experience. Eventually at one fine time, you can apply professional engineer, insyaAllah. So that my advice, tolong apply BEM untuk dapatkan graduate engineer. So itu pun penting juga sebab kita ni negara maju ni, kita pun ada di counted juga sebagai berapa banyak engineer ada dalam Malaysia ni. Kalau kita tak register, walaupun kita dah dapat mechanical engineer ke, automotive engineer ke, dapat scroll tu, dia tak counted. So kena register dekat BEM, Board of Engineers Malaysia. Okay, anything boleh WhatsApp me, boleh minta pandangan daripada Dr. Zul and so forth lah. Okay.
Okay, so
Terima
thank you.
kasih.
Kalau ada yang nak tanya soalan, boleh letak dalam comment section, kita akan try. This is from Shimpe. Does UTM have club or activity about the family student, or is it possible available in the future? Okay, maybe this can be answered by a lecturer from UTM. But so far we have club which is SAE, Outtech Club. They will involve directly in this kind of activities for Malay students and so on. Okay, so you can contact the student club, SAE and also Outtech, which is directly, Outtech is directly for automotive student. Okay, later on you can contact that one. And maybe I have some question before just in waiting for other question from the student. Dr. Izzal, aside from what, because you also know that that you're involved in our curriculum also, you have come as our IAP. So aside from what we teach and talk to our student in class, what is maybe what is the important skill that student need to prepare themselves before they go to become an engineer?
Okay, to become an engineer, dia what I can advise, if you want to do something tu, like I'm referring to my ni lah, my apa bosses lah, Datuk Rashid If you want to do something tu, dia ada tiga cara kita nak buat benda. Satu buat dengan hati, satu buat dengan kaki, dan satu buat dengan tangan. So if you want to do something tu, buat something with your heart, with your passion. Passion tu comes from your heart. Mana you are willing to do it, yalah, buat secara rela lah, not someone force you. Kalau you buat macam tu, you will enjoy what you are doing. And then like I said, what you need to prepare to, okay, at the same time, you make sure that you need to identify, kita kena kenal someone, so make sure nanti in the future, we will meet them again. Okay, kita better, we work in the team, we kena baik-baik lah dengan kita punya team members, and also kita kena baik dengan kita punya supervisor, kita kena very good relationship dengan kita punya university, sebab kita ni represent kita punya ni lah, kita punya department, kita punya university. Nanti bila kita in the future we give talk, we will talk about our university juga kan. So kena make sure benda tu all in very good relationship. Kalau boleh contribute as much as you can lah. Tell what you can provide, what you can contribute to your university, rather than you ask what university can provide you lah kan. Can give platform to you. What can you contribute yourself to the university. So prepare, and I think networking and communication skill. Sometimes we have many ideas, but we don't have a right platform to channel kita punya idea tu. Itu pun I rasa mungkin tadi yang someone ada yang soalan student tu pun, which is good lah. UTM maybe can provide a right platform for student to grow lah, supaya dia boleh channelkan, dia boleh conveykan the idea to the right platform. And then like UMW, kita as an industry, kita pun akan identify which university yang have a very good prototype that can be commercialized. So I would advise juga for university, not only look into technical matters sahaja tau, look on the demand and needs juga. Like I mentioned, financial, commercial and legal matters. Financial tu kebanyakannya di universiti, contohnya all the chemical department for instance, dia memang mencari all the novelty ni sebab boleh buat paper lah, dapat bagi high impact factor and so forth kan. Tapi nak mendapatkan that material tu very expensive. Memanglah you kan dapat high impact factor punya ni, tapi when you want to commercialize tak viable pun, sebab dia punya, kalau you nak commercialkan that product, nak benchmarking dengan produk-produk yang ada in the market, harga tu jauh lagi murah daripada apa yang kita nak buat, apa benda yang kita nak jual. So no point juga. So please take consideration that another three perspective lah, commercial, financial and legal juga. That's my opinion lah.
Okay. Other thing, normally student, that's good.
Betul lah.
Okay, Dr. Izzal. This question, okay. So, does a good automotive engineer require PhD?
No. Sebenarnya tak. Actually, automotive engineer, contohnya di Proton, dia tak require PhD pun. Dia require experience. Nak jadi a good engineer, you need a very really experience. You have minimum 10 years working experience in automotive field. So forth. Sebab when you involve in automotive, in engineering industry, engineering field, you will meet a lot of problems, and how you solve the problem itu yang akan make sure you ada value kat situ. It will make you grow. Contohnya kalau macam, maksudnya once you habis dekat automotive engineering di UTM, you apply masuk any automotive company. I take Proton lah sebab I was working with Proton kan. Proton, okay. Start from you, the first day you masuk tu, you akan start tengok industri punya experience, you belajar apa. Di Proton we are using CATIA, we not using SolidWorks. Tu pun saya ada mention dekat IAP tu, mungkin UTM pun kena consider using CATIA juga, sebab I think Pro 2 and Proton using CATIA. Dia kata, and then you akan dapat problem problem from market. We are having problem with this, so let's solve the problem together. So you meeting people. Kalau powertrain engine department, you meeting the vehicle department, you meeting with safety department. Okay, you kenal orang, and then you kenal problem, you kenal component, and then you still growing, and then dalam masa sama tu you ada masuk training on the build and dismantle, buka pasang engine. You will know every single component of the engine, and then every single component tu you kena tahu material dia apa. Kenapa engine biasa pakai casting, dia punya proses dia casting. Kenapa turbo pakai forging? Forging ni disebabkan nak naikkan tensile strength, nak naikkan dia punya maximum pressure to sustain, to remain the high pressure of the turbo. Dalam masa sama, okay, lepas tu you pergi training Katia pula, you pergi NVH, you learn about NVH Idiada. So every single time tu, every year tu, you learn, you have a very experienced engineer. So nak menjawab balik soalan tadi, it not require PhD, tapi cuma kalau you ada PhD, is good sebab you tahu in detail. Dan I would advise juga nak buat PhD ni better ada industrial experience supaya senang bila you buat PhD tu, you boleh relate apa yang you buat dengan apa benda yang industri ni tengah buat. Sebab kebiasaannya kalau yang kebanyakannya yang buat, mungkinlah, I tak cakap secara generalnya, kalau buat degree, master and PhD ni, dia tak nampak apa sebenarnya needs from industry. Apa yang sebenarnya industri ni face problem apa sebenarnya. Sebenarnya contohnya I can give some example in fact di Imperial College juga. Sebab alhamdulillah saya ada 6 years experience kat Proton, and I know I've developed with my team together on the turbo engine. So I know what is the hurdle nak design the turbo engine ni, comparison between turbo and naturally NA engine, naturally aspirated engine. Apa yang we need to consider, engine oil kena berapa spec, and then dia punya maximum cylinder pressure kena berapa spec, all the crankshaft macam mana design and so forth. Baru saya buat PhD, and bila I buat nak set up engine dekat lab tu, dia macam quite simple sebab kita dah tahu dia punya experience tu memang help me to grow masa buat PhD tu. Kalau buat, in fact masa I buat PhD tu, banyak student master dan juga PhD yang kat Imperial, dia banyak tanya sebenarnya heat transfer turbocharger ni apa sebenarnya, what is the relationship dekat dalam engine. Dia memang tahulah kalau yang Imperial, you know, is very advanced university, very top university. Equation, when I ask them, they can buat dia boleh buat XY, all the equation memang very, tapi sebenarnya what application tu mungkin kurang sebab dia tak involved in that situation sebelum dia buat benda tu. So I would advise engineering ni, working industrial experience tu is more valuable to become automotive engineer. Okay, tu je lah. Okay, Izzal. Okay, thank you.
Okay. One more question here. We have a short opinion on EV cars in Malaysia, and also I would like to ask to add one on this one. On EV, related to EV, how long do you think that this EV can be well established and accepted in Malaysia?
Okay, nowadays memang all in fact banyak kereta dah, ada several kereta yang bawa masuk EV ke dalam Malaysia. Dan what I can say, the infrastructure readiness tu perlu ada di Malaysia dulu sebelum kita nak full swing to EV. Dan I think EV punya manufacturers pun need to be ready on the battery thermal management system, sebab you know Malaysia is a very hot country. Anything ada effect dia dengan high humidity. Kalau contohnya yang we want to import the car tu, kita kena make sure that EV car tu is suitable to be used in Malaysia. Readiness macam infrastructure lah. Every single station tu kalau boleh kena ada ready that charging station, and then kena calculate juga the charging time. I think now currently berapa minit ada zone untuk full charge EV ni. Dan sekarang ni
tak ada yang laju sangat ke apa, fast charging pun mesti lagi.
Ada yang fast charging kan, ada fast charging. Okay, fast charging, tapi cuma I think currently ada juga several company yang approach BMW untuk ada satu teknologi on the EV batteries. very quick, 6 minit
6
full
minutes.
charging. Tapi I pun nak kena validate. Adalah several ada discussion. So every company ni dia tengah compete to make sure once the EV ready in Malaysia, the infrastructure tu ready tapi cuma tak time consuming. Contohnya kalau kita nak refuel, RON 97 ke 97, it takes about how many minutes untuk ni kan. Kalau contohnya kita berjam-jam, take many hours to recharge kita punya EV, which is maybe pain point dekat situ lah. Mungkin disadvantage on the customer. Nevertheless, ada juga yang jenis BMW yang you boleh charge kat rumah kan. Tapi itu is a hybrid. Ada yang pakai bateri, pakai EV, dalam masa sama pakai ICE. Kalau yang full EV ni, I would say maybe in 5 years if the infrastructure is ready, bolehlah pakai EV. That's my humble opinion.
Okay. Thank you.
Dan kalau saya boleh tambah lagi, Dr. Zul, berkenaan dengan CO2 emission, semua nak towards hybrid and semua nak towards EV ni disebabkan kita nak one of the effort nak reducekan CO2 emission. CO2 emission sebab kita punya fuel petrol, diesel tu memang ada hydrocarbon yang create emission lah. So sebenarnya orang cakap bila kita nak ban ICE ni, internal combustion engine ni, kita nak pakai ni, sebenarnya kita tak perlu ban pun ICE. Cuba kalau kita pakai hydrogen combustion engine, ada beberapa company yang dalam investigation, in fact ada prototype punya stage yang menggunakan hydrogen as a fuel. Hydrogen dia punya byproduct dia adalah water vapor. Tapi the ice is still there, but the main culprit is hydrocarbon tadi lah. We can still use ice, but maybe we can use the hydrogen punya fuel as an alternative fuel lah. Tapi cuma itu ada another question pula, bila nak set the hydrogen refueling macam mana? Dekat mana? Maknanya kena ada readiness of hydrogen refueling pula lah.
Infrastructure jugalah.
Infrastructure juga. So government kena main peranan dekat situ untuk make sure infrastructure ready supaya end user boleh dapat that benefit lah.
Okay, maybe we go to one or two more question. Doctor, I have a question. What is the requirement if we want to join your company in the future? And saya nak tambah terus satu. Do you accept internship from university?
Okay. Saya jawab Dr. Zul dulu. Kalau nak buat internship, yes, we accept internship. Intern from university. I think I join UNW ni 2019. I dah dapat macam 5-6 internship buat di UNW lah sebelum UIRDC establish. UIRDC establish, I accept two intern from UniKL. Tapi university ni dia apply intern melalui UNW HR. Kena refer HR juga. Boleh. Memang we accept intern tapi kena go through UNW HR. Nanti HR akan buat arrangement, dia akan positionkan suitable candidates ke UIRDC lah. Sebenarnya bukannya ke UIRDC, ke R&D center je, dia akan pergi ada yang pergi ke industri, ada yang UNW industry, ada yang pergi UNW corporation, ada yang pergi UNW finance. So we accept intern, but for R&D ni you have to go through UNW HR. What is requirement? Okay, kalau R&D ni memang saya pun banyak juga interview student. Kalau saya nak interview student ni, saya suka tengok apa you punya involvement dekat university, dan I suka tengok final year project. I nak tengok you ni how outstanding you are. You are follower ke ataupun you leader? What is the innovative idea yang you create supaya bagi create something creative to the product ataupun to the project yang you buat. So I lebih suka someone yang not above standard lah, tapi through that interview lah. Tapi nevertheless you can, I think to the student you can maybe in the fine time, maybe saya pergi UTM ke, boleh have a chat with me kan. Basically I can share with you what is the kind of innovative and creative punya idea ni yang you can trigger someone. Dia ni ada idea, this is something phenomenal, this is something, create something special, create value add. Maknanya I can value add. If I join your company, I can ni. Tapi dalam masa sama tu you still learning. Effort of learning pun ada, attitude kena ada. Good attitude kena ada. Dalam masa sama tu you have an effort to learn something new and proactively. So dia banyak kriteria requirement to join my company. Tapi nevertheless I open and this is the platform I nak bagi pada all the engineers to grow lah, rather than kita bagi sedikit diversify idea. The platform tu not only automotive, kita ada all engineering types dekat dalam UMW UIRDC ni. Wallahualam.
So this is our last question. Bagaimana cara untuk kita mendapatkan idea dalam menyelesaikan masalah atau membuat perkara baru di alam pekerjaan dalam bidang ini?
Okay. Terima kasih Aiman Loy. Okay. Dia nak menyelesaikan masalah ni, dia actually we have several macam mana nak menyelesaikan masalah ni. Kalau kita just masuk dia industri, kita tak boleh macam from nowhere kita dapat selesaikan masalah tu. Like I mention, kita kena ada experience. Tapi for a young engineers ataupun new staff, biasanya dia akan pergi training lah. Kita ada buat one structured punya process to problem solving. Contohnya macam saya rasa UTM pun ada TRIS kan. TRIS ni problem solving kan. Dr. Zul Hasni yang dia bagi ni kan. Dr. Zul Hasni. Okay. Problem solving tu sama lah. Dan juga kita ada juga 5-step design thinking process. 5-step design thinking process ni, kalau kita ada some masalah tu, dia ada 5 thinking, if I'm mistaken. Ada empathy, define. Dia ada 5 thinking, so maksudnya dia ada 5-step design thinking. So maybe you can, dia ada, you can Google, you can, I think the first one is empathy, define, ideate, prototype dengan testing, something like that. So maksudnya kita kumpulkan semua dulu masalah, kita buat, kita divergekan dulu. Macam I cakap tadi lah, open innovation, we get the problem, what is the problem tu, we ask people. Kita tak boleh solvekan problem tu seorang-seorang. Kita kena tanya subject matter expert, kita kena tanya university, kita kena baca literature review, kena baca journal, kena tanya subject matter expert, orang yang lebih experience. Kita kumpul semua maklumat and then kita kena define, kita kena converge pula. Okay, this is the problem, this is the main problem. Kita dah identify this is the main problem, baru kita come up dengan solution. Dia ada step dia tu. Dia memang sebelum ni pun memang my team pun ada pergi Inovasi Malaysia yang buat that problem solving. So I would advise kalau yang baru masuk industri, dia ada macam beberapa training course untuk solvekan the problem. Okay?
Okay, so this is the last of the last.
Okay.
Okay. So any comment on solar car in the future? This is an interesting question because we have seen the solar car development have been there for 10 or more than that. But what about that one?
Okay. Terima kasih Dr. Zul. Okay, solar car ni sebenarnya solar tu dia absorb energy from sunlight. Okay, dan dia akan di-storekan pada bateri. Okay, dia sebenarnya solar car ni memang, in fact dekat Tokai saya pun memang ada apa nama, masa saya final year tu, this quite well known juga in Japan. 2007 tu memang dah ni lah solar car ni, tapi dia buat dekat endurance, dekat dekat circuit, dekat Fuji circuit tu, kat Fuji circuit, all the ni solar car. Tapi untuk solar car ni, it's okay, it's green. Tapi cuma as a end user, kita as a passenger user tu, how far the solar car, kalau solar car itself, full solar car, kita get that matahari pun efficient satu hari berapa lama je kan. Dia macam dia ada intermittent lah juga, waktu malam tak ada kan, maknanya dia just we use back the energy storage in the battery lah. So possible, tapi not for long distance. Tapi I tak rasa full solar car ni suitable. Dia kena ada full solar car, dalam masa sama tu ada additional engine nak support that solar car lah kan. Mungkin yang tadilah yang EV ke, ataupun dia boleh integrated. I think that's possible. Okay. Terima kasih. Okay.
So that's all for today. Thank you very much to Dr. Izzal again for the presentation and the question and answer session, which covered a vast area. I hope that our students have gained a lot of information, knowledge for during this session. Thank you again. I hope to see you again, Izzal, in the future.
Okay.
And good luck to our student in your final exam that will become in one or less than a month. Okay. And Assalamualaikum warahmatullahi taala wabarakatuh. Goodbye.
Salam. Thank you semua. Alright.